Hi guys, and welcome to day one of our online instruction. Again, if you guys have used the videos at some point during this year, and I know a lot of you have, especially those days that I was out, this really isn't going to be too new for you guys. I know being able to ask questions may be a little different, and we're setting up some things to make that easier for you. But again, just keep in mind, I'll be available. If something can't be answered via email, fill out that video request, and I'll kind of make that video to kind of help you guys get through the process. So what we're going to do this week is we're going to look at rational expressions. So if you remember way before spring break, we did rational graphs. So rational graphs had all the asymptotes and all the things you had to learn, but the way they looked, it looked like fractions. So really what we're going to be working with are expressions that are fractions. Today we're going to focus on multiplying and dividing. So in order to multiply and divide these expressions, what you really need to be able to do is factor, and you need to remember the properties of multiplying and dividing fractions. So we're going to start just by reviewing that. Now, when you multiply fractions, you multiply straight across the top and straight across the bottom. What can make your life a little bit easier, though, sometimes is if you cross-simplify. And what we mean by that, if I actually do 22 times 81 and 27 times 44 and simplify, I'm going to get the same answer. Now, those are some pretty large numbers to work with. So what I'm going to do is I'm going to simplify diagonally before I get started. So 22 and 44 are both divisible by 22. I also can simplify 81 and 27. Now, again, you're simplifying here just enough to make this an easier problem for you. You may not know that 27 times 3 is 81, but you probably know these are both divisible by 9. So let's go ahead and start there. Now that we've simplified diagonally, we're going to multiply straight across the top and straight across the bottom. Now, because I didn't simplify this diagonal completely, I still have some simplifying to do, but I still end up with that answer of 3 over 2. All right, dividing fractions. All right, we talked about this before. Dividing fractions, it's easy as pie. You flip the second and you multiply. So what I do is I just rewrite this problem, and now I'm multiplying. Multiply straight across the top, straight across the bottom. If you want to cancel diagonally to start, you can. You do not need to. You'll still get the same answer as long as you simplify it in the end. But I'll go ahead and make this. This is 84 divided by 6, which does in fact simplify to just 14. All right, so before we get into simplifying these rational expressions, I want to go back to something that we've done a few times in class. And actually, this example should be looked a little different on your notes. I think I have this written as 2 plus or minus the square root of 48 over 2. So when it came to simplifying quadratic formula, one of the things you guys got really good at is remembering, hey, I cannot just simplify those 2's. I need to make sure I simplify this first. So we'll go ahead and we'll simplify that square root. So this would become 4 root 3. Okay, so you guys got really good at remembering that you do need to divide both the 2 and the 4 by this 2 because those terms at the top are being added or subtracted. What I saw a lot, though, especially towards the end here, is a lot of you guys did that, but you would just leave this as plus or minus 4, or not 4, you did plus or minus 2 root 3. Well, yes, those 2's do divide, but keep in mind, when they divide, it doesn't disappear. Okay, you're doing 2 divided by 2, so it's 1 plus or minus 2 root 3. And that's just something that we saw kind of come up a lot when we were doing quadratics here at the end. Okay, so that idea of simplifying, okay, the fact that it needs to be that 2, I need to take it out of both those numbers, we're going to look at that now when we get to rational expressions. So what I'm going to show you is a huge mistake that I see all the time that we need to make sure we're careful of. So number 1, x cubed over x cubed minus x squared. What you cannot do is just cancel out the x cubes. Everyone wants to do that. You wish that you could, but you can't. And the reason for that is, again, it's not, you can only cancel out factors. You can't cancel out individual terms that are being added or subtracted. Those 2 terms that are added or subtracted are their own factor. The only way you could cancel it out is if you had the same factor in the top. So to show you guys why this doesn't work, we're going to look at an example with numbers, and then I'm going to hope that makes a little bit more sense. So let's look at this first one, okay? X cubed over x cubed minus x squared. A lot of times, like I said, you want to just cancel out those x cubes. You cannot do that. Don't do that, okay? Very, very bad. So let's look at some numbers in its place, okay? Let's say I have 2 over 4 plus 1. Well, let's say, and actually let me rewrite this as 2 over 2 plus 1. So a lot of times we want to say, okay, great, cancel out the 2's. So that leaves me with 1 over 1, which is 1. The problem is the original problem was 2 divided by 2 plus 1, which is 2/3. Those are not the same thing. That's why it doesn't work. Okay, again, let's look at it with the example we just had. Let's say, hey, I can divide both of those by 2. That gives me 1/3. Well, the original problem was 2 over 5. Okay, they're not equivalent. It doesn't work. All right, so let's go ahead and go back to this original equation. Let's see, what do we do then? So what we do is we factor. Just like we did when we did the graph, we're going to factor first. So what I can factor out of the bottom is the GCF of x squared. Now I look at my factors. X squared is a factor. X minus 1 is a factor. Well, because there's an x squared both in the top and the bottom, I can now cancel that out, which leaves me with x over x minus 1. Now, the other thing that we're going to include in our answer is something called an excluded value. And what that means, basically, what we're listing is any value of x that doesn't actually work based on the original problem. So what that means, if you remember, back when we did rationals, we couldn't divide by 0. We never can divide by 0. Try it in your calculator. Any number divided by 0 does not exist. Okay, it's undefined. Can't happen. So any number that makes the denominator equal 0 is going to be an excluded value. So what we do is we look at any point in this problem. So let's look right here. I have two factors, x squared and x minus 1. The values that make the denominator equal 0 are 0 and 1. Now, because those are not possible, you cannot divide by 0, all we include in our answer is that x cannot equal those two things. So even though that equation simplifies to x over x minus 1, if I actually plug in 0 there, it really doesn't work, because if I plug in 0 in the original equation, I have 0 divided by 0, which does not give me an answer. All right, let's try another one. Again, first step, we factor the denominator. So x squared is a GCF. Then from here, from looking at the factors, both the top and the bottom have an x that can cancel out. So that leaves me with 2 over x times 4x minus 1. We're going to list our excluded values. Anything that makes the denominator 0. Well, 0 and 1/4 are my two answers. All right, then looking at the last one. Again, you cannot cancel the x squareds. You cannot simplify that 2 and that 6. Again, if I do that, let's look at an example with numbers. If I have 6 plus 1 over 3, okay, that's 7 over 3. But let's say I do what we just talked about, and I try and simplify this and say, hey, good, that's going to be 2 plus 1. That's 3. 3 is not the same thing as 7/3, okay? That does not work. So again, what we do is we factor. Well, in this case, the only thing I can factor out is the GCF of 2. So since that 2 is able to get factored out, that 6 is multiplied, it's not added, so I can simplify that 2 and 6. And I get my final answer. And again, list our exclusions. The denominator can't be 0, so x cannot equal 0. All right, so now we're going to get into multiplying and dividing. And honestly, guys, I think the simplifying is, not that it's harder, but it gets missed a lot because you guys just try to do these so quickly. So the first one's going to be a little bit different. The first one's actually more of an exponent practice question than it is kind of this rational type function. So this is really going to review our exponent rules that we just did. So again, to work this problem out, if you want to cross-cancel to simplify some things, you're more than welcome to. I'm going to go ahead and just multiply it out and simplify from the end, because with all the x's and y's, I think it just makes it a little bit easier. But work it out whichever way you think makes sense. So I'm going to multiply across the top. That gives me 54, x to the 7th, y cubed. Then I have 6, x, y to the 4th. Then from here, it's just an exponential expression. 54 divided by 6 is 9. This is x to the 6th over y. Again, at any point, the denominator cannot be 0, which means that x cannot equal 0 and y cannot equal 0. Because again, at this point or at this point, x was in the denominator. And you cannot have a 0 in the denominator. All right, so now let's look at a problem that's going to look more like the rest of the questions that we're going to see. So whenever we have problems like this, the first thing we want to do is factor. Everything that we can factor, we need to factor. So I'm going to start by factoring the top left. There's a GCF of 5x there. That leaves me with 1 minus x. The bottom, that's going to factor into x minus 3 and x minus 1. This is x minus 3 and x minus 2. And this is 5x. So now this is when the cross canceling is really helpful. Anything either top and bottom that cancels out, whether it's diagonal or straight up top and bottom, then we can cancel it out. So for example, 5x and 5x, those are going to cancel out. X minus 3 and x minus 3, those are going to cancel out. So now let's look and see what we have left. That is a minus x, that kind of ran into it. Okay, so at this point, it may look like you're done. This one's really tricky, okay? We need to be careful. So what you can actually do here, 1 minus x is the same thing. Let's take that negative and factor out that negative. So I'll just write it up here. If I were to factor out a negative, then this would become, let me rewrite it. Let me rewrite this as negative x plus 1. That might make it easier to see. So now let's factor out that negative. So 1 minus x is actually the same thing as a negative x minus 1. Well, if I rewrite that in that way, you can see I have more to cancel out. That x minus 1 factor is now top and bottom, and I'm left with this final expression. Now you can write it like this, or you can write it like this. Either way, it's up to you. Just keep in mind, basically when it comes to your answers here, your answer either needs to be the numerator or the denominator, needs to be either fully factored or fully multiplied out in standard form. Either one's okay, but you kind of can't have this mix of it's kind of factored and it's kind of not. The last thing we need to include are the excluded values. So any value that made the denominator equal 0 is going to be excluded. So let's go back to when we factored. And let's look at the denominator when we factored. Look at the 0 of each of those factors. Each one of those is an excluded value. So for x minus 3, that means that x is not equal to 3. For x minus 1, x is not equal to 1. And for 5x, x is not equal to 0. So those are my excluded values. All right, so now we're going to look at division. So with division, guys, it's very, very similar. You just got to be careful with your excluded values, first of all. And second of all, remember to flip the second and multiply. But again, first thing I'm going to do is I'm going to factor. Factor top, factor bottom. So there's a GCF. X comes out. And then the bottom right is going to factor into x minus 6 and x minus 5. Now, the first thing I'm going to do to make this a little easier, I'm going to go ahead from this point right here, list my excluded values. Well, x is not equal to 5, and x is not equal to 6. Because again, those values make the denominator 0. All right, well now, let's go ahead and when I divide, I flip the second and multiply. So now it's the exact same problem we just did. And let's see what we can cancel out. Well, x minus 5 and x minus 5, x minus 6 and x minus 6. And then I've got an x here. Can cancel out with one of those x's there. So I'm left with 7x squared over 2. But keep in mind, when I flip this, I now have another denominator. And that denominator cannot equal 0. So I already have 6 listed as one of those possibilities. But x is also a factor. So x is not equal to 0 as well. So this is the simplified expression, and those are my excluded values. All right, let's try this last one. Again, remember, if you divide a whole number or you divide something that's not a fraction, just remember that's really over 1. All right, now let's start with just factoring. Okay, well this is the first one we have where it's 3 terms and a is not 1. So remember, when a is not 1, we've got some extra steps. So I need to split my middle and do grouping. So figure out what multiplies to negative 90 and adds to 1. Well, that's going to be 10 and negative 9. So I'm going to split the middle into those two numbers, and then I'm going to do my grouping. So out of those first two terms, I can take out 2x. Out of my next two terms, I can take out minus 3. Then I have a common, that same factor. So 3x plus 5 is the first factor. Everything that's not shared is your second factor. All right, so now I'm going to rewrite this. So this is 3x plus 5 times 2x minus 3 over 4x squared. And it's divided by, I'll go ahead and factor. X can come out there. And it's over 1 right now. Okay, so first step, list the excluded values. Look at the denominator. Any factor that makes the denominator 0. Okay, so x is not equal to 0. Flip the second. And before we cancel out, let's go ahead and list any new excluded values that I now have. Well, x I already considered, but 3x plus 5 is a new factor in the denominator. So the 0 of that factor would be a negative 5/3. So those are my excluded values. Again, any value of x that makes the denominator 0. All right, now let's see what we can cancel out. So 3x plus 5 and 3x plus 5, and that's it. So I'm left with 2x minus 3 over 4x squared times x, which would be 4x cubed, with my excluded values. All right, so the last one that we're going to look at looks more complicated than it actually is, okay? What you have to remember, you really have two fractions that are being divided. And whenever you see something that looks like this, what you really need to do is rewrite it horizontally. I think it just makes it a lot easier to work with. So this is x plus 1 over x squared divided by x minus 2 over x. Once you write it this way, guys, it's the exact same problem we've been doing. We'll list our excluded values, flip the second, list any new excluded values, cancel out, and I get my simplified expression. So anytime you see a fraction on top of a fraction like that, I just think it's simpler to rewrite it horizontally. And then again, we're dealing with the same kind of problem we were just dealing with.